In the last video, I ended with an example of a mutating method, which is a method with side effects. I passed a string builder object, a mutable object, and the method changed its value. Before I try another example, for the sake of completeness, I wanted to mention that the warning on the parameter y for this method is not related to our discussion about the final keyword. If I hover over y now, you can see the warning is about y's value never changing. That's because we call the doxyz method once only, with a literal value of 16. Right, let's try another example. I'll create a logger class to emulate a class from an external library. I'll add it in a new package called external.util. I'll start with a method on this class. It's going to be public static and void called log2console and have a parameter of type char sequence called message. This means it can take either a string or a string builder argument. I'll use the local datetime class, which is like local date, but maintains information about both date and time, not just date alone. It also has a now method to get the current date and time. I'll print a formatted string using this datetime field and the message, the method argument. Let me pause here to show you a useful page on formatting date and time and where to get information about more format specifiers. There are many ways to format date and time. A couple of standardized ones are shown here. These apply to the formatted method on string as well as the printf method. This information was retrieved from the link I show here. I'll bring this page up. The specifier for any date or time data is %t. That is followed by any one of these conversion characters, and you can see there are many. A good place to start is the third table, which has 6 rows and are commonly used date conversions. I showed this table on my slide. Capital D and capital T are also easy to remember, so I'm going to use these. Capital T gives you the time formatted for the 24-hour clock in the format hour, minute, second. Capital D gives you the date as month/day/year. This slide explains the code I'm using in a bit more detail. It's common when using date-time conversions to use the argument index feature, which is called explicit indexing. This lets you list your date-time variable just once as an argument. You then use an index to tell the formatter which argument is used for which specifier. If you do use an argument index, you need to use it for all specifiers, which I'm showing on this example, using 2 for the message string argument. I thought it was important to review the format specifiers a bit, especially for date time. This seemed like a good place to do it, even though it's a bit off topic. Let's get back to the code and back on topic. I'll add one more bit of code to this method. I'll check if the message passed is a string builder. If it is, it gets assigned to the variable SB. I'll then set the length to 0. This effectively truncates the data in the string builder. Okay, so wait, why would a logging statement do this? Well, hopefully it never would. The point is, unless you examine every line of code, you don't really know if a method you're using might have side effects. I will now call this from my main method. First, I'll create a new string builder variable tracker and assign that a new instance, constructing it with the text step 1 is ABC. I'll call log2console on logger, passing it tracker. I'll continue processing, appending data to the tracker variable. I'll execute log2console again. Then I'll print out tracker. If you were just reading this code, you might guess that you'd get step 1 is ABC, a comma, then step 2 is XYZ printed out after 2 logging messages. Let me run this. As you can see, there are the logged statements with date and time in common formats, and after that, the message after logging, the tracker variable is empty. That could be a pretty confusing result. The log2console method has a pretty nasty side effect. It clears my string builder instance after each log statement is output. Are you really going to have to worry about every library class you use? Probably not, but there are some steps you can take, which is called defensive coding, to minimize risk. One simple thing I can do with this code is pass a string to the log message and not the reference. Let me change how I invoke those methods, and instead of passing tracker, I'll pass tracker.toString. Rerunning this code now. As you can see, the results make a lot more sense. After logging, tracker equals step 1 is ABC, step 2 is XYZ, So this code had no unintended consequences or side effects from calling log to console. It's very easy to forget that method arguments are copies of references. This is especially easy to overlook when you're dealing with collections and arrays. I'll be talking about making defensive copies in an upcoming video, but right now let's explore another problem caused by mutable objects. I'll create a new class in the dev.lpa package and call it mainMailer. I'll add a main method to it. In this class, I'll have a list containing duplicate names, then use a map to keep track of the counts for each distinct name. I'll also write some code to standardize names, which would be called prior to a mailing, to clean up names before they get printed on an envelope. I'll start with an array of names stored in an array of strings. I'll include two versions of Ann Jones, one with and one without the PhD suffix, and I'll have Bob Jones MD. Next, a simple Carol Jones, and then two Ed Greens, one's a PhD and one's an MD, and finally Ed Black. I'll set up a private static method that creates a random list of these names. It'll return a list of string builder objects. I'll call it getNames, and it will take an array of strings. I'll set up a local variable. This is the list I'll return, and I want it to be an array list. I'll use an index to determine how many names to add to my list for each distinct name. I'll return the list from this method. In this loop, I'm going to add a number of the same names to my list, determined by the value in my index variable. I could just add 5 of each, for example, but this will make the output a bit more interesting. A nested loop will loop from 0 to the current index value. I'll add a new string builder instance to the list, using the name from the array passed to the method to construct it. I'll increment index after each name so that I get a different number of names for each name in the array. Getting back to the main method, I'll first create a local variable, population, again a list of string builder. I'll assign that the result of calling my getNames method, passing it the names array. That should give me a long list of names with a lot of duplicates. Next, I'll set up a map of the counts of duplicate names. The key will be a string builder, and the value is going to be an integer. I'll call this variable counts and set it to a new instance of a tree map, so this map will be sorted. To populate the map, I'll loop through population. I'll use maps merge method. This lets me add a new name with a value of 1 if it's a name not yet in the map, or increment the value that's already in the map if it is there. After this, I'll just print my map. If I run this now, I get counts for each distinct name. Remember, the suffixes are included in the name, and that makes them unique. My population has 3 Ann Jones, but 4 Ann Jones that have PhDs, so some pretty smart Ann Jones. You can see each name has a different count because of the way I set up my population list. Just to confirm, I'll print out the number of PhD Ann Jones I have in the map. First, I'll set up a local string builder, setting that to Ann Jones PhD. I'll use the get method to obtain the count of how many Ann Jones with PhDs there are in my population. Running this now, I can see that I get 4 records for Ann Jones PhD, so that's good. Okay, now let's say it's our job to mail a flyer to this population. It's our company's policy to remove suffixes before printing the name on the envelope for privacy purposes, so I'll create a method called standardize names. I'll make it private static and have it that it return a list and accept a list. I'll set up a new array list. I'll loop through the list passed as the method argument. I'll add code here shortly. I'll return my new list of standardized names back. I want to loop through a list of possible suffixes. Right now I only have PhD and MD, but you can imagine others could be added. I need a local variable to hold an index. I'll check if the suffix is in the name and pass that index back. If it's greater than -1, there's a matching suffix and I want to strip that out. I'll replace the suffix with an empty string. And I'll add the cleaned up name to my new list. I'll call this from the main method and print out the clean names. Running this now to check if this code works as intended. And as you can see, I have a long list of names and no suffixes on any of them. If I was working with real mailing data, I'd have an address somewhere and I'd address the envelope with this simplified name and the address. Let's say I've successfully mailed my population and now I want to target all Ann Jones PhD records again for some reason. In fact, I'm just going to copy that statement that spans lines 23 and 24 and paste it on line 29. If I run that. I would expect to get the same amount I got before I standardized the names, but I'm getting null back. I'll print out my counts map next. Running that, I see something very weird. My tree map's names have all lost their suffixes. Not only that, but it also looks like I have duplicate keys in my tree map. There are 2 entries for Ann Jones, each with a different count, and also Ed Green is showing the same thing. That's ugly. What will I get if I try to look up just Ann Jones? I'll create a new string builder variable called Ann Jones and assign that a new instance with just the text Ann Jones. I'll print out the same message as before, but use this new variable to get the counts from the tree map. Running this. You can see I do get counts, but it's the counts for only one of the Ann Jones entries. This map is really messed up. Let me try something else. I'll loop through the map entries and see what I get. I'll print a separator line. I'll call for each on counts, and remember, that means I have key and value as the arguments, and I'll print those. Let's see what this produces. I do get each entry, each key, with individual counts. Now let me loop through the key set instead. I'll print another separator line. I can use key set to loop through my map's keys. I'll print k the key, then use it to get counts for that key. Now running that, I see that I get 2 different results. I get different keys and values when I loop through the map's entries, comparing that to when I loop through the keys and use that key to get the values. That's not good. The standardized names method, which seemed harmless enough, has produced a very ugly side effect on my map of string builders. It didn't matter what collection my string builders were in, they were all referring to the same group of instances in memory. A change to one variable in any collection will change that instance in memory. If that instance is a key to a mapped collection, you get into this ugly situation. This is why you should use an immutable object for keys in a map so that this never happens. Okay, so these are 2 examples of side effects and the dangers that are possible if you're using mutable objects but not programming defensively. The good news is that there's strategies for managing change so you can reduce or eliminate side effects like these. Java provides mechanisms to control changes and extensibility of your code at many different levels. You can prevent changes to data in instance fields, which is called the state of the object. By not allowing clients or subclasses to have access to these fields, you can prevent changes to methods by not allowing code to override or hide existing functionality. You can prevent your classes from being extended. You can also prevent instantiation of your classes. I'll be reviewing each of these in turn over the next couple of videos.